Suppose the roots of x to the fourth minus 3x squared plus 6x minus 12 equals 1 are alpha, beta, gamma, and delta. Find the value of this monstrous expression. This is a question from the Caltech Harvey Mudd math competition. I think that's the name. Tiebreaker number 2. Okay, so let's dive right in. Now, the first thing to notice here is, of course, that it's a pretty long expression, right? We probably don't want to find alpha, beta, gamma, and delta, then plug them in, then evaluate this. Obviously, that's not the idea. So there must be something else, right? Pause the video and see if you can figure out what there is besides that. But I'll give you a little hint. Look for patterns among all 4 of these terms over here and see if there's anything special that you notice. Right, and I'm hoping that you pause the video and try it out yourself because that's the best way to learn. But one thing that you can notice over here is that you've got alpha, beta, gamma in the numerator and delta in the denominator. Then you've got alpha, delta, gamma in the numerator and beta in the denominator, and so on for all of them. So it's kind of symmetric in that sense, right? Now, given that it's symmetric, if we can find a pattern with one of these, it'll probably apply to the rest of them as well. And the pattern over here that we can do is just, or notice, I should say, is alpha plus beta plus gamma, right? And I'm going to write gamma this way because it's the way I learned to write it. So hopefully it's easier for me to write than that. So it's equal to alpha plus beta plus gamma plus delta minus delta, right? Okay, sorry, by the way, about how slow I'm writing. My tablet is lagging a lot, so it's pretty hard to write with it. And then, yeah, this is going to be divided by delta squared. And, initially this might look like it's even more complicated than what we had earlier. But we know what alpha plus beta plus gamma plus delta is, right? This is just the first symmetric sum. It's a sum of all the roots, right? Because these are the roots. And you know the formula for the sum of roots. Now, you might think it's 3, right? Negative 3 over 1. But notice that it's x to the fourth, so we would need the coefficient of x cubed, and that's just going to be 0, right? It's 0x cubed, meaning that the sum alpha plus beta plus gamma plus delta is nothing but 0. Okay, what does that tell us? Now we've got 0 minus delta over delta squared. So that is negative 1 over delta. Then similarly, right, and this is why the symmetry is important, you have negative 1 over alpha. Yeah, I mean, I wrote alpha and it came out as a 1. And then minus 1 over beta and 1 over gamma. And this, hopefully you should recognize, is also symmetric. I mean, yeah, obviously it'll be symmetric, right? Same as what we had earlier. And we can, do a little bit of manipulation here. We can take out a negative 1, for example. And now we get negative 1 over alpha. And I'm not going to write out the whole thing because you get the idea, but it's negative 1 over alpha plus 1 over beta, 1 over gamma, 1 over delta. It looks very similar to what we've seen in the past with the sum of roots. And luckily for us, there is a relation that we can use. Okay, now the relation that we use is basically taking the, actually, I don't know what it's called, but basically you flip all the coefficients. Okay, and that gives you, when you, when you invert the coefficients, what you're going to end up getting is the roots of that are going to be 1 over the roots of the initial equation. Okay, and you can prove that just by dividing by x to the fourth, and then you'll get something like that, and you can do it. I'm not going to go into all of that right now. The important thing is to just memorize this equation because I'm not going to see it when I scroll down. So x to the fourth minus 3x squared plus 6x, and then something else. So what is that? That's x to the fourth. I already forgot. Minus 3x squared plus 6x. Oh, this is terrible. Sorry. Yeah, I mean, maybe I broke the pen or something like that, but it's like so slow. 6x, and then be a little careful here because this is probably another area to get tricked on. It's minus 12 equals 1, and of course we want it to be equal to 0, so that just becomes minus 13. The same idea now of having that coefficient, I mean, yeah, maybe it looks like a 15 to you, but it's supposed to be a 3. Sorry about that. This is equal to 0, and now when we want to flip it, well, we're going to end up making the, okay, sorry, I'm just getting mad now, 1 second. Yeah, no, that's not a 15, that's a 13. Okay, I almost messed that up. Yeah, when you now invert them, you're going to get negative 13x to the fourth, blah, blah, blah. So let's just multiply it by negative 1 once and see what we get. But actually, okay, we don't need to do all that. I'm definitely not inclined to write all of that again. Remember, what we want, what we're going to want over here is a sum, negative the sum of the reciprocals of the roots. So we flip the coefficients, we get negative 13x to the fourth plus 6x cubed. and we want, so negative 6 over negative 13 is 6 over 13, and I believe that's correct, and then you multiply by negative 1, so it should just be negative 6 over 13. Now maybe I messed up some of the algebra here, it's very possible, but I would have written it out properly, but even the answer looks ugly. It's negative 6 over 13. So yeah, I mean, I don't know, I think that's correct. Yeah, maybe I made a small mistake, but this is definitely the right idea to follow, so hopefully that makes sense to you guys. So sorry for how bad it's been. If it goes on this for other videos, I recommend just fast forwarding and just seeing the equations I write. But yeah, sorry for the delays in this. If you watch this far, thank you so much, I appreciate it. Make sure to subscribe and follow along. Hopefully my little Wacom tablet will be better and I'll be able to write properly. But until the next video then, I'll see you soon. Bye bye.